All right, guys, we are going to go over factoring by the GCF, greatest common factor, and grouping. So remember, when we're talking about factoring, what we're thinking about is we're looking at numbers and we're trying to break them down. My dog is in the room. We're trying to break them down to the smallest numbers. So if we had, for an example, 24. What two numbers multiply to give us 24 other than 1 and 24? Well, there's lots of ones that we could start out with. One could be 2 and 12. So I know nothing else goes into 2, so these are two factors of 24, but I can still break down 12. I can break down 12 into two other factors, which would be, say, 3 and 4. Now, 2 is prime, so I can't break 2 down anymore. 3 is prime, I can't break down 3 anymore. But 4 is not prime. I can still break down 4 into a smaller factors. What two factors multiply to give me 4? What numbers multiply to give me 4? That's what I'm talking about factoring. Numbers that multiply to get that number. So 4 breaks down into 2 and 2. So if I were to completely factor the number 24, it would be 2 times 3 times 2 times 2. These numbers all multiplied together would give me 24, and since each one is prime, I can't break down any of them any further. That's what we're doing with factoring. We're trying to figure out what are the math terms that can be broken down to the very smallest prime numbers to give you that multiply out to give you what the number is given. We're not going to go over this whole worksheet. We're going to do some of this just to get a basic understanding, and then we'll go on to some homework. So we're looking at the greatest common factor, GCF. That is the biggest number that divides into two or more numbers evenly. All right? So when we look at 24 and 42, we're going to look and see what numbers multiply into 24. Well, we know that 1 and 12 and 1 and 24 and 2 and 12 and 3 and 8 and 4 and 6. So all of these are factors of 24. 1, 2, 3, 4, 6, 8, 12, and 24. What numbers multiply to give you 42? 1 and 42, 2 and 21, 3 and 14. 4 does not go into 42 evenly. 5 does not go into 42 evenly. 6 goes into 42 times 7. And that's it. So my factors of 42 would be 1, 2, 3, 6, 7, 14, 21, and 42. So what is the biggest number that is common between both 24 and 42? Well, it looks like it would be 6. 6 is the largest number that goes into both 42 and 24. So my GCF would be 6. In 81 and 90, it would be 9, 15 and 33, 3, 40, and 8 would actually be 8. Okay, if you don't understand how to get those, work out all your factors, line them up, and compare and see which one is the biggest one that can go into both of those evenly. All right, when you're looking at variables, you are basically going to take, if the terms have the same variables, you're going to take the variable with the smallest exponent. So x squared could come out of both x to the 4th power and x squared. That would be the greatest common factor among those exponents. In this situation, I have a's. The smallest exponent that is in both of these would be a squared. Would leave me with 1, but that's okay. The smallest b that is in both would be 1. I don't even have to put the 1 because we know that the 1 is implied. So this would be the greatest common factor among these variables. The greatest common factor among these would be, I can actually take out a 3. This term has an x, this term has an x, this term has an x. So I know I can take out at least one x. What is the smallest exponent of x's? Well, this one has 2, this one has 1, this one has 3. So the smallest exponent would be my 1x, or x to the 1 power. This term has a y. This term does not have a y. This term has 2 y's, but if all 3 of them do not have it, I cannot take one out. So that would be my greatest common factor. Okay, so if I've been given a trinomial and it says find the greatest common factor, all I'm going to do is look for the common number or common variable among all 3. 5 divides into 5, 5 divides into 20, 5 divides into 15 evenly. So I can take out 5. X, x, x. So I know I can take out at least one x. How many x's can I take out? 3. But this is smaller exponent of 2. This is the smallest exponent of 1. So therefore I can only take out 1. What am I left with? X squared, because 5x to the 3rd divided by 5x is going to leave me with x squared. That is what goes there. What am I left with here? 20x squared divided by 5x is 4x. 20x squared divided by 5x. 20 divided by 5 is 4. X squared divided by x is x. 15x divided by 5x is going to give me 3, and then the x's cancel out, so I'm left with 3. So if all I'm being asked for is to find the factor using GCF, this is all I'm asked to do. Now, you guys know that we can extend this on and factor this even smaller, but that's not what we're asked to do now. What about here? What number can be factored out of this? 4. Does 4 go into 12? Yes. Does 4 go into 20? Yes. So I can take out 4. A. So I know I can take out at least one A. What is my smallest exponent? I've got a 5, I've got a 2, and I've got a 3. My smallest exponent is going to be 2, so I can take out A squared. When I divide it by A squared, for A squared, what am I left with here? 4 divided by 4 is 1. A to the 5th divided by a squared is going to give me a to the 3rd power cubed. Plus 12 divided by 4 is 3. A squared divided by a squared is 1. So I don't have anything else there. Minus 20a cubed divided by 4a squared. I'm doing that for each term. I just didn't write it down for each term. 5. 20 divided by 4 is 5. A cubed divided by a squared is a. All right. So I'm just taking out the greatest common factor. Okay. What about here? What's my greatest common factor here? 2, 10, and 8 all have a 2 in them. So I can take out 2. Now, generally, we do not like this first term to have a negative. So let's go ahead and take out a negative 2. What about the x with the smallest exponent? What do I have? This has a 3, this has a 6, this has a 4. So x, the smallest exponent would be 3. So when I take out negative 2x to the 3rd power from negative 2x to the 3rd power, I'm left with 1. 10x to the 6th power divided by negative 2x to the 3rd power, I'd be left with negative 5. 6 minus 3 is x to the 3rd power. Oops, sorry guys. Then 5x to the 3rd. 8, negative 8x to the 4th power divided by negative 2x to the 3rd power equals negative 8 divided by negative 2 is positive 4. X to the 4th divided by x to the 3rd is just x. So that's what I'm left with there. This is basically all I've done is taken out my greatest common factor. This, in our factoring situations, this would be step 1 as we step further. Right? All right, so going to our homework. Then we talked about, okay, so it says factor the common factor out of each expression. Is it asking us to do anything more than just find the GCF? No, read the instructions and make sure you're not trying to do more than what it's asking. All it's asking is to factor out the common factor. So in this situation, I'd be factoring out 5. Each of these numbers is equally divisible by 5. Can I factor out an a? The a is not in all terms, so no, I cannot. So when I factor out a 5, I'm left with 7a squared minus 15a divided by 5 is 3a plus 40a divided by 5 is 8. Now you know we can forward on and factor this smaller. However, we're not asked to do that. This is all it's asked is to factor out the common factor, the GCF. So that's my answer. If it said factor each completely, then we would need to break this down further. But this one's just talking about the GCF. So in this one, what's my greatest common factor? I see that 6 is my biggest number, so I'm always going to try and start with 6. Does 6 go into 12? Yes. Does 6 go into 24? Yes. So then I know that 6 is going to be my largest factor because 6 goes into 6 one time. That's going to be my largest, and hopefully it'll go into all of them. Except I kind of jumped the gun, didn't I? Because I forgot to leave room for my V's. How many V's can I take out? I've got 9 v's in the first term, v to the 9th power, v to the 6th power, v to the 5th power. My biggest, I've got v's in every term. My biggest, or I'm sorry, my smallest exponent is 5. So I'm going to take out the smallest exponent. So negative 12v to the 9 divided by 6v to the 5th. I would be left with negative 2v to the 4th. However, since that's my first term, I'm going to make this negative. I forgot to do that. Sorry, so this would then be positive. 2v to the 4th. Then I got 24v to the 6th divided by negative 6v to the 5th. And what am I left with? Negative 4v. Oh my goodness. I already had my negative there. And then 6v to the 5th divided by negative 6v to the 5th is going to give me negative 1. So minus 1. So when I take out my greatest common factor, this is what I'm left with. That's a 5. Okay. Now, since it says factor these completely, that is when we need to do, we've got, notice, these are polynomials. When we factor polynomials, we factor out by grouping. So if we go back to the notes, when we did this, remember, here are our steps. After we factor out our greatest common factor, this one doesn't have a greatest common factor, but after we factor out the greatest common factor, we're going to group them. We're going to group the first 2 terms together. We look at the variables, make sure that they're in descending order. The first 2 terms factor together, the second 2 terms factor together. What comes out of these 2 terms evenly? I've got 2 and 5. 2 does not divide into 5 evenly. I've got an n and an n, so I know I can at least take one n out, and I'm going to look and see my smallest exponent is n to the 2nd. So I can factor out n to the 2nd. When I factor out n to the 2nd, 2n cubed divided by n squared, I'm left with 2n. So 2n goes there. When I factor out n squared from 5n squared, I'm left with 5. So minus 5. Then whatever this sign is, when I'm grouping, I bring that down. Plus, what number goes evenly into 8 and 20? Well, 8 doesn't, but I know 4 does. So if I were to take out 4, can I take out another n? There's an n here, but there's no n there. So I can't take an n out. I can only take it out if it's in both terms. So when I divide 8n divided by 4, I'm left with 2n minus, and then 20n, or I'm sorry, 20 divided by 4 is 5. Now, of course, we want these to be the same, because what we're saying now is this term and this term have these 2 things in common. So we can factor those out. So I'm going to take my n squared and my plus 4, and I'm left with n squared plus 4 times n 2n minus 5. This is the answer I'm looking for. So we've basically broken down this 4-term polynomial into the 2 factors that multiply to get it. Okay? Now, let's do some on the homework. So, if I take, let's do number 8. Is there a greatest common factor? So I have to look, greatest common factor. Is there a greatest common factor? It would be 4, because 4 goes into 4, 1, 4 goes into 4, 4 goes into 16, 4 goes into 16. I cannot take any variables out because this has 3, this has 2, this has 1, but this has none. Unless they all have it in there, I'm not going to take it out. So when I take out my 4, I'm left with n cubed plus n squared minus 4, negative 16n divided by 4 is 4n. 16 divided by 4 is 4. So now that I've factored this out, so here is my GCF. Now I can start my grouping. I have 4 terms, which means grouping. If you have only 3 terms, you can't group. You have to have 4 terms. So make sure you understand when to group and when not to. You use the grouping with 4 terms. So what do these 2 terms have in common? Now I'm just looking at this group. What does that 2 terms have in common? Well, one is n cubed, one is n squared. I can take out an n and I can use my smallest exponent, which would be n squared, and I'd be left with n plus 1. Then I take this sign and bring it down, but now I need to remember, since I'm taking a negative out, I need to change my signs. So what's common between these 2? Now I'm grouping the second group. What's common? I see that I can take out a 4. It's a negative 4. What am I left with? Negative 4n divided by negative 4 is going to leave me with positive n. So I leave positive n in there. Negative 4 divided by negative 4 is going to give me positive 1. So I get positive 1. And lo and behold, these are the same. Yay. So I can then combine my outside terms, n squared minus 4, n plus 1. However, I'm not done because I have this 4, this GCF out there. I need to make sure I bring him into part of the answer. So this whole thing, I've got 3 terms that multiply to give me this in its very prime form. Okay? We'll do one more. Let's do this one here, because these are big numbers. One benefit of factoring out your greatest common factor is you can work with smaller numbers. So I'm going to look and see, 16 is my biggest, or is my smallest number. So I'm going to say first, can 16 go evenly into these? I know it can go into 48, but it cannot go into 20 or 60. So I know it's not 16. The next biggest number that evenly divides into 16 is 8. But 8 does not evenly divide into 60. The next biggest number that divides evenly into 16 is 4. And I do know that 4 goes into 60. I know that 4 goes into 48, and I know that 4 goes into 20. So 4 is going to be my greatest common factor. So when I factor 4 out, I'm left with 15m cubed plus 12m squared minus 5m minus 4. Now I've got my greatest common factor out. I've got 4 terms, so I need to use my grouping. So I take my 2 terms and my second 2 terms, and I group them. So what is common between these first 2 terms? I'm only looking at these terms now. So I know that the biggest number that can go into both of those is 3. But I can also factor out an m because both terms have an m in it. So I know I can factor out 1. 2 is my smallest number, so I know I can factor out 2 m's. And I'm left with 5m plus 4. I've divided 12m squared by 3m, and I've divided 15m cubed by 3m, and I'm left with 5m. 12m squared divided by 3m squared is 4. Then I bring this negative down. There is nothing that goes evenly into both of those. So what do I do? Well, I can always factor out a 1. However, it is a negative 1 because I've brought this sign down. And since it's a negative 1, my signs need to change. So this needs to become positive. However, look at that. We like that because now all of a sudden, these are the same, which is what we want. So, that doesn't look like a very smiley face. So, now I take my outside numbers, 3m squared minus 1, and my 2 binomials that are the same, 5m plus 4. That's my answer, except, dun, 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 remember to bring your 4. Okay? All right, I hope that helped.